our life searching for the sense of belonging. Some people die before they fulfill their desires. Such a waste of existence. Spend our life searching for the sense of belonging. Some people die before they fulfill their desires. Such a waste of existence.
Anxious earth is rising. Anxious earth is rising. I'm so happy.
We spend our life searching for the sense of belonging. Some people die before they fulfill their desires. Such a waste of existence.
Hey, Double Trouble here. How's everyone? Haven't streamed in a long time. Looks like I got audio there. This is the Double Trouble channel. And I haven't streamed in a long time, so it's gonna take me. It's been almost a week since I streamed. No, it's been about a week since I streamed, I think. So it might take a few seconds for me to get into the swing here. What I wanted to do, I want to do a review of Contact. You know, that the sci-fi movie Contact with Jodie Foster. I want to do a review of that. But it's like a 2.5 hour movie, and it's take a lot of effort to get that organized. But I will work on it. Maybe tomorrow night, Saturday. Saturday's a movie night, right? So we could do it on Saturday. It's just a matter of, you know, it's a long movie. It's a 2.5 hour movie plus there's a lot in the movie. You know, I mean, it's not like one of these movies where it's just you know, long just for the sake of being long. You know, there's just a lot of content in the movie, a lot of stuff going on in the movie, and it's, you know, multiple levels and all that kind of stuff. So it's a little bit involved to do a review of that film, and I won't be able to do it justice, but I'm gonna give it a try. So maybe tomorrow night we'll do that. And what I have been doing is to do a you know, watch the movie and then review it after we watch it. But you know, that just seems like it's just. I mean, people can. It's a retro. You know, it's been out there for 30 years, almost, and I'm sure everybody's seen it already. So I don't think we need to actually watch it, you know, on stream. We can just talk about it. I'll just put a thing up there that says spoilers, so everybody knows, you know, not to watch the review until they watch the movie or something, because there are a lot of spoilers in that movie that can be, you know, messed up with a review. So, although I'm sure everybody's seen it by now. Anybody who's into sci-fi, I'm sure, has seen that film. Although I don't know, it's kind of esoteric. I don't know, it's not esoteric, but it's you know, there's a lot of technical stuff going on in the film that maybe people, you know, general audience might have difficulty with. Although it's they do a Hollywoody thing to it, you know, they make it Hollywoody. They put a lot of action and there's a romance, and you know, there's a lot of stuff in there that, you know, average audience would probably want to see. So I guess we could do that. So yeah, do some stuff here. All right. Let's see here. I got to type in something here just to make sure. All right. There we go. I got a computer here that's kind of slow, you know, and it takes a little bit of, you know how you on a slow computer you type and then it takes a while to catch up. It's one of those situations. So we'll get that figured out. Make sure we get this here. Yeah. All right. Yeah. Everything's delayed. My stream is delayed. You know what I do is I set this thing up on I stream on the fast computer, the computer that can handle streaming. I you know, I don't have a lot of. I got really old computers and stuff like that. So I stream on. I got one computer, and it, you know, I had to buy some extra memory for it and everything to get it to work for streaming. So I got that one working for streaming, and then I have another old laptop or something that I use for monitoring my stream, because the way OBS works is you can't rely on what you're seeing, what OBS says is being streamed, and what actually is being streamed. So I don't. I have to run another computer and stream and view my own, lurk my own stream, you know, to make sure that it's working. So, yeah. So that's what I do. And the problem is that the old laptop is not fast enough to do stuff. So when I try to type into it, it takes a long time, and then it interrupts me when I'm trying to stream. I'm talking and I type in at the same time. So, all right. So, all right. Plus, when you get older, it's harder to do things, do more than one thing at once. When I was young, I could do dozens of things dozens of tasks going all at the same time. But as you get older, there's something about your short-term memory or something that's like the first thing that starts to degrade when you get older. Actually, your brain starts to slow down in your 20s. They say after your 20s, then it starts declining. I don't know if that's true or not. I didn't really start to feel it until I got into my maybe 50s or something like that. But yeah, it goes down, just like your physical and everything. It goes down. The performance goes down. I can still do stuff like programming and things like that, stuff that I had done, quite a lot of, even though that requires a lot of short-term retention, of information. As you're programming, you got to remember, what you did at this part of the program and when you're writing this part, and remember what all the variables mean, and go back and forth, and but for some reason I can still do that kind of halfway, at least not as well as I used to, for sure. But new stuff like this, when I tried to learn this OBS, that was really difficult to learn. Although afterwards I found out that that's pretty much everybody who tries to learn OBS has trouble with it, and the ones who have enough resources just hire a producer or somebody to handle all that stuff for them. But I don't have that, so. But one of the thing that I wanted to do, I don't know if you've been watching the last few streams that I did. My mice have been failing. I had like 3 mice fail, or two or three mice that just petered out on me. This one here this was my last mouse that I had. You see it says intermittent. This is intermittent. So it's kind of. So I bought another mouse. Let me get that here. I'll show you that. So I bought this mouse at it's called ONN, on, I think. But I bought it at Walmart. As soon as I plugged it in, I knew it was a problem. It acted like it was installing malware. Sometimes if you get a USB device that's been hacked, you plug it into your computer, it can install malware onto your computer. And I thought that's what it was doing. I'm not sure if that's what it was doing, but it was not. It was messing up my computer. And it finally took a shit. So I had this one mouse with an intermittent button on it that I had to move from one computer to another, and I decided, well, instead of getting another mouse, what I'd do is get one of these little pads, that you write on, with a little thing, a write-on pad. And so that's what I did. Damn, your stream is so interesting. I got a chatter here, Mary. Yeah, thank you, Mary. What do you like that's so interesting about it? How long have you been stream? I've been on stream for 14 minutes. If that's what you mean. Yeah, this, for those of you who are watching this on a VOD, this is a live stream on Twitch. Obviously, it's pretty scuff here. And we have the chat. Twitch has a facility here where people can chat in, type in and ask questions and stuff like that, and make comments. And I got somebody here who is asking me questions, how long I've been streaming, and ask if I play games and generic type questions. So, what do you like about my stream, Mary? So anyway, I got this pad here, this writing pad, and this pencil. You want to get Wacom, right? One of these things. Instead of a mouse, it was a little bit more, but I got a used one, cheap, as cheap as I could, and it was a little bit more than a mouse, but at least I know it's going to work. And I wanted to try that out on a stream. I've been trying to learn how to use it, and it's quite different than using a mouse or a touchpad or something like that. It really is, takes some getting used to, you know, how to use it, practice, you know. So I'll try that today, and see how that goes. Let me check this again here. Just see what we're doing. Okay. Okay. I got 7, so we go like that. Okay. So what I wanted to do, as a way to try this thing out, is to do a word problem, and try to work it out. I've done this kind of stuff before. I did how to convert from Celsius to Fahrenheit. I wrote it as Celsius to centigrade just for fun, as a joke. But it was hard to do just talking, you know. And I tried one stream. I tried just pointing the camera down at the desk and writing on a piece of paper, you know. And so this is kind of a handy thing that it's good that I have this, because then I can use it for you know, especially when I'm talking about technical stuff and sciencey type stuff and, you know, all that kind of stuff. So that's what I wanted to try out today. So let's do a word problem and see how this works out. Let's see if I can bring it up. Okay, there it is, I think. All right, yeah, and there's my mug and everything. Look at that. Okay. All right. So I was trying to find. I got the tablet, and I said, okay, what kind of software is out there that will do it? You know, I thought about GIMP or something like that, and that's just, you know, it's too big, too hard, you know. And a couple other ones I looked at. Libra Draw. I couldn't even, when I ran that program, I could not even find the toolbar to make it draw a line. I couldn't even draw a line in the frickin' program. LibreDraw. The user interface was so impenetrable. You know, I brought it up. I tried to draw something, and it made a box. It tried to select or something, and then I tried to, anyway, it was. So what I found was this thing called Tux Paint, which is a program for kids. And I thought, great, that's what I need. I need something that's super easy to use. So that's what we get. It's called Tux Paint, and it has sound effects too. Maybe I'll figure out how to get rid of that if it gets too annoying. But you can draw with it. Does that make a noise? Can you hear that? Okay, my stream is so laggy here. I'm gonna try something here. Sorry for this goofiness here. Oh, look at that! They gave me. Oh, Twitch is giving me transcodes here. That's kind of cool. Okay. All right, so let's see how long we're delayed here. Okay, it's only about 3 or 4 seconds. I can live with that. Oh, now let me see if it's... All right. Yeah, you can hear that. Okay, that's good enough. All right. Is this loud enough too? I didn't know if I got the volume right here. Okay, here we go. All right, so, let me erase what I just did. I got an eraser here. And I just noticed something. This thing is not sound effects. That's the eraser sound effect. I just noticed that the performance on this draw program is really sluggish because I'm running OBS at the same time. So my computer is really well, it says that it's only at 18%, but it's this program is just really sluggish. Okay, so this is what we're going to do. We're going to do this word problem. So here's the word problem. Okay. Train leaves the station at 12 p.m. as promised in the title of my stream. There's a train that leaves the station over here at 12 p.m. going 70 miles per hour. You like these kind of problems? Some people like them and some people hate them. This one's kind of funny. And just a warning: if you're trying to learn this kind of stuff, don't watch this. This is just for fun. This is not going to be instructive for people who are trying to learn this kind of stuff. It's fun. If you understand how these problems work, then maybe it will be entertaining. But other than that, don't watch it to try to learn how to do these problems. Because I saw this. I saw another streamer do this a while back. As far as I can remember it, this is how it went. And they worked it out. That streamer worked it out with algebra and stuff like that. And I'm going to try to work it out without algebra. I'm going to try to just work it out just by reason and simple math, if we can do that. And it's not going to work. It's going to fail, but it'll be funny. All right. So we got train leaves the station at 12 p.m. going 70 kilometers per hour. Let's go kilometers per hour here. Yeah. Kilometers per hour. Let's see if I can write that in here. Kilometers per hour. Okay, so we know what our units are. And then another train over here, 500 miles away. I'll write that in there. Or kilometers away, rather. I'm in the U.S., so I'll say miles sometimes by mistake. So this is 500 kilometers. It kind of works. And it leaves at 2 p.m. same day. That's 60 kilometers per hour, heading the other direction on a track. So the question, I don't remember what the question was. I think the question was when and where do they meet? I think that's what it is. You got to figure out when to figure out where anyway. So where in a track do they meet and what time do they meet? So that looks kind of complicated, doesn't it? I mean, if you look at that, you say, wow, how do you figure that out? That looks kind of complicated. And if you were going to do this with algebra, you'd say x equals, this and y equals that and all this kind of stuff and put it all into equations, all the information that you have. You have this information here, you have this information here, and you'd have a series of equations. And then maybe you'd have enough information that you could substitute some stuff into different equations, or whatever, work it out that way. But I'm going to try to work it out just using reason and simple math, if we can do that. So first thing you want to do to approach this problem, I would want to make the problem simpler. It's complicated right now. You got two different speeds. You got them leaving at different times. But the track is the same. You get 500 kilometers of track. So how do you make it simpler? Well, one thing is to make them leave at the same time. But how can you do that? How can you make them both leave at the same time? You can't make this guy go back in time. So, I mean, you could probably, but you don't want to do that. So let's start the thing at 12 o'clock. 12 o'clock, this train leaves, okay? It goes 70 kilometers per hour. And then at 1 o'clock, it'll be at 70. Let's see here. Let's see. That's about 250 right there. see, let's call that 100. I should use a ruler. Maybe use a ruler. That's okay. Let's say that's 100 and this is 200. This is 300. And that's 400. And that's 500. Let's try that, huh? That looks pretty close. Warning. Just in case anybody's confused. All right. Okay, so we got not to scale. All right. This is not to scale. All right, the tracks and everything is not to scale. So this guy starts at 12 p.m. All right, in 1 hour he goes 70 kilometers, right? So that's pretty easy. So we can say if that's 100, let's say 70 is right about here. 1 hour he goes 70 kilometers. He'd be right at there, and that would be 1 o'clock. But that's still a different time than what this guy's at, 2 o'clock. So if he goes another hour, it would be 2 o'clock, which is the same as this guy. That makes it a little bit easier. So let's go another hour at 70 kilometers per hour would be 140 kilometers. So there's 100. Let's see right there. Let's see, that's 140. They got a line drawn here, but I just 140 kilometers. So that makes it a little bit easier. So now that's at 2 p.m. Right, at 2 p.m. he's going to be right here. So now the problem is a lot easier. And we assume that these trains are already moving when they leave the station. They're already at speed. You know, they started a few hundred feet back in the track and got up to speed before they left the station. Just so we don't have instant acceleration and squish everybody in the train or something. All right, so we got 2 p.m. 2 p.m. So now it's a lot easier. It's 2 p.m. This train is right here instead. And we can say, oh, okay, at 2 p.m., both these trains leave at the same time. This one's going 60, this one's going 70. That makes it a lot easier, doesn't it? We don't have to figure out the different times and stuff like that. So in some amount of time, these trains got to cover this here, which is 360 kilometers. That's a little bit easier. And how fast are they going? In classical physics, they're approaching each other. You just add their speeds to see how fast they're approaching each other. Right? If this one's going 70 miles towards this guy's doing 60 miles towards this guy, then they're approaching each other at 130 miles per hour, right? 130 miles per hour. Kilometers per hour. Kilometers per hour. So that makes it a lot easier. So we know now you divide and it's 3 hours, right? 3 hours. They're gonna hit each other. So that makes it makes it really easy, right? If we want to figure out where this guy is going to be in 3 hours from here, right? Because we restarted, right? From this point, we do 3 times 70 kilometers per hour gets us 210 kilometers. Right, from here. So 210 plus 140 is 350. So he's going to be at, oh man, which I should have labeled my marks here. There's 140. There's 250, 350. It's going to be right about here. So this train will be right here. Heading that way. Right? This train will be over here. Then, all right, where will this train be at 3 hours? Okay, so it's going to be 3 hours times 60 kilometers per hour. It's going to be 180 kilometers. All right, but it's minus from 500, right? Because he's going backwards. He's going from 500 to 0. Right? He doesn't make it to 0 though, because he bumps into this train, or supposedly. So 500 minus 180 is let's see, 500 minus 180 is going to be 0, 2, 3. So he's at 320. So you go, why there's 250, 320 right here. All right. So remember, this guy was at, what was this guy at? Let's see, this guy was at 350. I should have put that in here. 350. And this guy going this way is at 320. Okay. It's kind of complicated. So what have we figured out here? We figured out that the train in the eastern, right? We'll go east is to the right, and west is to the left, right? Let's do it that way. So the train that was in the eastern part, heading west, traveled at 60 miles per hour for 3 hours, and he ended up at 320. Okay. And the one that was heading from 0 on the west coast, heading east, ended up at 350. But something's wrong here, isn't it? Look at that. How did that happen? So obviously it's a trick question, right? See, because there's a little extra track here that they went around to cross, right? They had to have a little switch and a little track there or something to go around, so they could pass each other, right? It's a trick question. But no, actually, it's a trick answer. It's not a trick question. It's a trick answer. So do you know where I made my mistake? Now, I actually made this mistake when I was trying to do this. This is what happens when you try to do it without using the right math. Try to do it in your head. Yeah, I tried to do it in my head, and I ended up with this. And I said, how can that be? And I went back and I figured out what the problem was. So I'll give you a second to figure out what the problem was, or you can stop the video or whatever. We're live. Nobody's watching it live, so it doesn't matter. So if you're watching the VOD and you don't know what the answer is, there was a mistake. I made a mistake. When we got to this point where we figured out that it had to go 360 miles, and they were closing in on each other at 130 miles per hour first of all, I mean, that's correct. They are closing in on each other. 70 plus 60 is 130. That's pretty easy, right? You can do that in your head. But then to find out how much time, if they're going 300, 130. Now we'll do math, right? 130 kilometers per hour. And you do 360 kilometers. And you divide that out. Kilometers cancel each other out. Right? So you're left with hours. And it's 360 divided by 130. That is not 3. That's not 3 hours. That's where I screwed up. When I did it in my head, I did that way. So if you were following along and you caught that, kudos to you for catching that. But that's where we messed up. So if I do 360 divided by 130, I can't do that one in my head. I might be able to do it, but let's see. So that's 2.769. Oh, it's a repeating one of those repeating ones. After a while, 2.769. So that's how many hours, and so this is equal to 2.76 hours. And if we want to figure out how many hours and minutes, just take the 0.76, multiply that by 60 minutes per hour, and that will tell you how many minutes. And it's 45 minutes, about 45.6 minutes, so about 45 minutes. So approximately 2 hours and 45 minutes. See, 45.6 minutes. Right. So now if we go back and we say, okay, this guy's traveling 70 miles per hour for 2 hours and 76 minutes. 2.76 times 70 kilometers per hour. That puts him at 193. So 193 plus 140. Shit, oops. 93 plus 140. Puts him at 333. So this guy is actually heading this way. All right, let me clean this up a little bit. Okay. So let me do a little bit more cleanup here. This is a learning. This is me to learn how to use this thing. Actually, that's the whole purpose of this thing. All right. All right. So actually, this guy ends up at what did I say? 333, approximately. So there's 250. No, just put it right here. 333 kilometers down the track. And this guy doing 60 kilometers per hour. See, 60, that's what was given in the thing. 60 kilometers per hour for 2 hours and 76 hours, 2 hours, 2.76 hours. So I go 2.76 times 60 and I get 166 approximately. 166. So he starts here at 500 and he goes 166. So if we do 500 minus 166, 500 minus 166, this guy ends up at 334. So there they are. Right. I was rounding, so I mean it's the same spot, right? 333 and 334. So that makes more sense, right? That's where they bump into each other. It's right there, 333 point something miles or kilometers down the track, and it's about 2 hours and 45 minutes, a little over 2 hours and 45 minutes. Yeah, at 2 hours and 45 minutes, they would see each other and know that they're going to crash. and there's nothing they can do about it because they're doing 60 and 70 miles per hour, kilometers per hour. So that's it. That's the mess that I made. So that's why I told you not to listen to this if you want to learn this stuff, because I messed it up. Now I messed it up unintentionally before, just figuring this out in my head, and when I found my mistake, I thought, oh, that would be fun. That would be a fun thing to do on stream, to mess it up on stream, just to fuck with people's heads. So that's what I did. All right, so that's pretty easy, isn't it? All right, let me get rid of this all stuff now. Let's see. Is there a way to wipe this whole thing? Undo? Wait, let's see. How do I do this? Eraser, new. New. I think I just say new. Everybody got that? You got that down on your notes? You just rewind the thing. I wonder if lecturers do that anymore. Do on-stream lecturers, do they pause? I know when you're in class, you know, or in a seminar or whatever, they will, during the lecture, they'll pause, you know, they'll write stuff down, and then I'll pause for a second, make sure everybody catches up, and they grab an eraser. That's what they used to do. It used to be chalk, you know, a chalkboard with erasers, and did everybody get this? Okay, I'm gonna erase it now. You know, you don't have to worry about that anymore because it's all on video and stuff, and people can just, you know, oh shit, what do we do here? No, don't bother saving it. It's on the video. I don't have to save it. There we go. All right. But yeah, everything's on video now. So if you didn't get something written down, if you do that, I don't even know if people still do that. I think you do that, right? You still write stuff down because you don't want to, because it helps you remember more. I think kids students still do that. I don't know. But if you didn't get it written down, you can just rewind the video, you know. All right, so let's see. Oh yeah, let's convert Celsius to centigrade. All right, so we want to convert. Let me try something else here. There's another feature here. How big is that? Is there a way to control how big that is, I wonder? Let's see here. Convert Celsius. How do you spell Celsius? Celsius. Did I spell that right? Centigrade. Let me check my spelling on that. Let's see here. I'm going to check my spelling here while I'm. Google knows how to spell stuff pretty good. Usually. All right, let's see. Celsius. Okay, I think oh, it's a S instead of a C. Okay, Celsius. What was the other one? Centigrade. Centigrade. Okay, that one I think I spelled right. Okay. All right, so it was an S. Undo. Oh, it's not undoing for me. Shit. Okay, not sure what I did here. There we go. Okay. Now I forgot how it was spelled. All right, Celsius. Celsius. Like Celsius. Well, I'm going to say convert, right? Convert. Convert Celsius to centigrade. Okay, that's a handy thing that everybody wants to learn, right? How to convert Celsius to centigrade, right? You want to learn how to do that, don't you? Okay, here's how you do it. Now, the Celsius scale, 0 is freezing on a Celsius scale. So, if we want to go, all right, let me draw a scale here. Oh, look how slow that thing is. Oh my God. Oh my goodness, look at this, how slow this is. It's just drawing a line. Why is it so slow? Wow, didn't even get it straight. So in Celsius, 0 is freezing, and 100 is boiling of water at some standard temperature and pressure. So that's a Celsius scale. And if you want to convert that to centigrade, then you take your Celsius temperature C, Celsius, and is equal to temperature centigrade times 1. So that's how you convert from Celsius to centigrade. I didn't do my 1 very well. Fix it up so people know what I'm talking about there. Just so it's clear what we're doing here, just so nobody gets it wrong. That's a 1. So yeah, if you want to convert from Celsius to centigrade, you take your Celsius temperature, multiply it by 1, and you get centigrade. I know I did that backwards, but I think you still understand. All right, so that's how that works. Is that chatter still out there? That bot? Let's see. I'm an art designer, and I made stuff for Streamer. I made stuff for Streamer. If you don't mind, I want to made one art picture for you in free of cost. Oh my God. No, that's okay, Mary. I got a drawing pad here now that I can draw my own pictures. Look at how high quality they are too. They're really high quality. Look at the quality in that thing. All right. So, but if we wanted to do a, but if we want to actually convert to Fahrenheit, right? That's what we want to do. Because we're in the U.S. and they're backwards. They don't know anything. Oh shit! How am I going to spell Fahrenheit? Here, capital F. That's good enough. I don't know how to spell Fahrenheit. I have dyslexia, for those of you who are unfamiliar with the stream here. I'm dyslexic. I've just lexical dyslexia and social dyslexia, which makes things really interesting. All right, so let's get rid of this. Don't want this anymore. I didn't realize this thing would be so goddamn slow while I was streaming. Look at this, how slow this is. Yeah, well, that's okay. I'm slow anyway. All right, so how do you want to convert this to Fahrenheit? Well, we know that Fahrenheit is 212, right? Isn't it? I think that's what it is. 212 is boiling for Fahrenheit. Let me put the little thing up here. This is C. This is F. And that's not minus. Put that in there as a. That's kind of confusing. All right, and then and at freezing, we know it's 32 degrees. Yeah. Excuse me. Fahrenheit. Yeah, the way this works out is that to convert from temperature Celsius. Let's see. If you want to convert from temperature Fahrenheit is equal to temperature Celsius times 1.8 plus 32, right? So the 32 is right there. That's obvious, right? There's the 32. If you had 0 here, if this came out to 0, if this was 0, this would come out to 0. You add 32, right? That's where the 32 comes from, is because Fahrenheit is based on 32 as freezing for water, whereas Celsius, that same temperature for the freezing water, is 0 degrees. That's where the 32 comes from. And the 1.8 is just the scale. It's just the, the Fahrenheit has more little ticks in it in between than Celsius does. Another way to think of the 1.8 is 9 divided by 5. So in some cases, maybe it's easier to multiply by 5 and multiply by 9 and divide by 5 to your Celsius temperature, and then add 32 to it to get Fahrenheit. And another way to look at that is that it's 18 degrees for every 10. Right, same ratio here, right? So what you could do is you could say, okay, if we go 10, 10, 10, 10, 10, 10 all the way up. Now this is where I need my ruler. Do they have a ruler on here? I don't know. I don't want to. The stream is already fucked up. I don't want to go through all that. Wait, they might have a ruler on here. Let's see. Let's see what they got here. This is. They got so many different things in here. Look at all this stuff. Yeah, I don't think they have a ruler. All right, forget that. All right, so I'll try to do this, eyeball it here. Okay, we'll just do 50 is in the middle, right? That's 50. And then we'll take off 5 here, right? At 5, 1, 2, 3, 4, 5. Okay. That's not bad. All right. So you know that every 10 here, every 10 degrees here is going to be 18 over here, right? Because we did 10. This is Celsius, like, you know what I mean? The ratio. You see how that's working out? This one starts at 32, but every 10 steps it goes 18. That's the ratio between those two. You kind of get a feel for it, right? If you're thinking, okay, this one goes up 10, this one's going to go up 18. This, you know. Anyway, I think you understand how ratios work, right? Get that figured out. All right, let's see here. Let's do it. Let me erase this and make this a little bit better. A little bit smaller. What I could have done, I should have put that 0 down there. Because we're probably not going to do much. All right, so this is going to be 32. 10 is going to be 32 plus 18, which is 50. 20 is going to be 50 plus 18, which is 68. So you can do this yourself. If you don't have a scale, if you need to convert, and you don't have access to a computer or a device or anything, and you gotta figure this stuff out, and maybe you don't even remember this formula. All you remember is that it's 18 to 10. You can figure it out. You can write your 0 down here for Celsius 0 and 32. That's pretty. You remember that, right? And then go from there. You know, do 18, 18, 18, 18 like that. So 30. It's going to be 86. Because 68 plus 18 is 86. And then 40 degrees Celsius, it's going to be 104. Did I do that right? Did I add that up right? And then 50 degrees is going to be 122. And 60 degrees, don't know, could happen, right? Global warming and all that. We might hit 60 degrees in places sometime. I don't know. Plus 18 is going to be 140, right? Did I do that right? Am I adding this up right? 18 and 122 is 140, and then 70 is 158. See, we didn't have to. All we needed to know to get this whole chart here is just we know that 0 is freezing in Celsius, and 32 is freezing in Fahrenheit, and it's 18 for every 10. That's all we got to know, and we can figure out all the rest of it here. Well, I'm gonna erase this and put this up a little bit higher, so I can have room to write that other in there. Yeah, I don't know if this is going to work on stream once I actually want to do content with this thing. I don't know if this is going to work. So that's 80. 90. Could have moved that up a little bit. Let's do that. you can't see it from here, but that this thing is lagging so much. When I'm moving the pen, it's just really lagging, and it's because I'm streaming at the same time. Okay, so 150 plus 18 is 168. Now, if this works out right, then I should end up at 212. Oops, 168. And 168 and 18 is 186. Right, and 186 and 18. Oh shit, I screwed up somewhere. Where did I screw up? 120. Oh, here, this one. This should be 150, 160. How did I get to 150? Oh my god. Let me start over here again. Oh my goodness. All right. 140 is right, I think. And it even has a self-correction mode in it, because if you don't get 212, you know you screwed up somewhere. All right, so add 18 to this one would be 158. I was writing 0 instead of 8. I did that twice. That's kind of weird. Wonder what that means. 158. Okay, 158 plus 18 is 176. And 176 and 18 is 194. And 194 and 18 is 212. So there, it worked out. Okay. And we can go backwards too, right? If we can go to the minus side. So there's minus 10, minus 20, minus 30, minus 40. We don't need to go past minus 40. We're probably not going to do that, right? I mean, you might need that if you're doing experiments or something, but no, just walking around temperatures, you're not going to get below minus 40 too often. Now, there's something really cool that you're gonna discover here in just a second on the way this works. So now we're subtracting, right? We're subtracting 18 from each of these. So 18 from 32 is going to be 14. If I did it right, doing my math in my head here. And then 14 minus 18 is minus 4. And you see how that works? Subtract 18. Do it on your calculator, you'll see. Minus 4. And then minus 4 minus 18. So this one was kind of hard because you cross 0 to do it in your head, you can do it, but it's but once everything is minus, we're saying minus 4 minus 18, you can just add those together. 4 and 18. And you get minus 22. Now watch what happens here. Now minus 22 plus minus 18 is going to be minus 40, which is the same as the Fahrenheit. See that? I mean, same as the Celsius. See that? Did I do this right? I think it's worked out, right? Minus 22 minus 18. Yeah, that's minus 40. Yeah, so there's a double check there. You can check it over here. If you know that Fahrenheit is 212, I think most people know that. And you know that Celsius scale goes from 0 to 100, and 100 is boiling and 0 is freezing. You got to double check up here when you're building your scale from scratch. And minus 40 and minus 40 are the same in Celsius and Fahrenheit. It just works out that they cross. They're both the same at that temperature. And then you go to minus 50, then it goes below that. I mean, it goes. There, we'll do that. Minus 50. So this would be minus 58. Because we're subtracting another 18 from that. Okay, and then you can just keep going. If your math is good, you'll have the right scale. So this is kind of helpful. So now, if you want, once you got this little chart made up, imagine you're on a desert island somewhere and you want to convert from Celsius to Fahrenheit for some reason. I don't know why you want to do that, but you can do this from scratch, right? I'm not consulting anything. All I knew, I mean, I knew these ones because I worked them out before, but all you need to know is that 0 is 32 and 100 is 212. You don't even need to know this one if you get your math straight. And I knew that minus 40 was minus 40, so that was a double check going that way. And you can make this whole chart here just from memory. I mean, just from scratch without consulting anything. And then if you want to, and if somebody says, okay, how much is 25 degrees Celsius in Fahrenheit? Well, 25 isn't on our thing here, but we know that's 5. It's 5 degrees. And over here we know that every 5 degrees here is 9 degrees here. So we can just add 9 to this and get 77. So 25 is equal to 77, if I did my math right. And another way to work that out is if you're trying to figure out exact temperatures like that, is to take your Celsius times 1.8 plus 32. I'll just do that real quick here. 1.8 times what did I say? 25. Let's see. You see that? Times 1.8. We'll get it. Right. We'll get that number. And then we'll say plus 32. Plus 32 equal 77. I got it right. Okay. So if you need to do, if you're doing exact, you want point something or whatever, you want it to the decimal point, then you can do that. But if you're just estimating, somebody says, oh, how much? Somebody says, oh my goodness, it's 42 degrees out here, I'm dying, it's 42 degrees. And you go, well, how much is that Fahrenheit? I'm in America, I don't know that. How much is that in Fahrenheit? And then you can kind of get an idea. You can say, okay, 40 we know is 104, and 2 more degrees is almost 4 degrees. It's almost right. It's 4. It's so you'd say it's about 107. That's what I would guess, right? It's approximately 107 Fahrenheit. We can figure it out exactly if you want to. We can say 40 degrees C times 1.8 0, 32, 40. Oh, I screwed up here. Ouch. That's totally wrong. Well, I don't know where I got 77. That's the most bizarre thing. I don't know how I got 77. Sorry about that. "42 degrees is going to be, oh, I know what I did. So 40 is 104, and then it's going to be, if it was 2 degrees for every one, 2 to 1, then it would be 108. but it's going to be a little bit less than that because it's 100, so it's 107. That's what I did. I said 77 instead of 107. All right, let me continue over here. So we got 72 down here plus 32. Oh, that's not right either. God, I can't believe this. What did I screw up here? Two times 40. We got the dot, dot, 272 plus 32 is 104. That's that temperature there. Oh, I multiplied by the wrong one. It should have been 42. Jesus Christ. Let me start over. Don't try this at home. Alright, let's start over again. Whoa, this is so slow. Glad nobody can see me doing this. Alright, let's start over again. We'll start the whole thing over again. Alright. Alright, so somebody says, it's 42 degrees. I'm dying. And us in America say, well, 42, that's not hot. And we go, okay, let's convert that to Fahrenheit. There we go. Alright, so to convert to Fahrenheit, first step is to go 1.8. I estimated it. Remember, I estimated it at 107. Because I said 40 is 104. And so if you added 2 degrees, if the ratio was 2 instead of 1.8, it would be 2 more or 4 more degrees, which would be 108. But it's not. It's a little bit less than that because it's 1.8 instead of 2. And so I estimated 107. So it's going to be close to that. It's going to be close to 107. And so we're going to try to add that up and see if we can get to 107. Or close to it, how close it actually is to 107. Okay. So 4.42 degrees times 1.8. So this would be 16. Carry the 1 is 33. We got a dot there. It's going to be 42. Dot. Plus 32, right, because our formula up here, plus 32. So we're pretty close. It was actually closer to 108 than I thought. So you can get so that's one way to do it. Or you can just add the 2. If it's close like that. If you need to try to do this in your head, there's a way to do it in your head. I don't think I could do it right now. I'm so tired and confused right now. But if you wanted to do this in your head, you can, to multiply something by 1.8. That's kind of hard to do in your head a little bit. I mean, you know, it depends upon how good you are at math. To do all this in your head, is maybe you can do it, maybe you can't. But one way to do this easier is to say that this is the same as multiplying by 2 and then subtracting 10%. That'll do the same thing as multiplying by 1.8. And this is a lot easier to do in your head. Multiplying by 2 is easy, right? Anybody can do that right in your head. Just about any number you can do 2. You can multiply by 2 in your head pretty easy. Any short number. And then subtract 10% is also pretty easy to do in your head. If you if you do any kind of work in sales or anything like that, estimating, and you can easily subtract 10%. So if we were going to try to figure this one out, we want to take 42 times 1.8. Another way to do that is to say, okay, let's try to do this in our head. I won't even use the pen, but we'll take 42 times 2. That's 84, and then take 10% away from 84. 10% from 84 would be minus 8, right? 8.4. So 84 minus 8 would be 76, and it's 8.4, so you minus 0.4 from 76, and you get 75.6. And then we can add 32 to that, and it's the same thing down here, right? 107.6. So that's the way. It's a little bit easier if you have to do it in your head. It's easier to do this. I find it easier to do this, these two real simple things, than to try to do this in my head. So, if you had to do it in your head and you needed it to the decimal point, I find this is a little bit easier to do in my head. If you're just, trying to estimate, if you're going to be doing it all the time, just remember what these are pretty easy to remember. They're very easy. Look at these numbers here, right? 30 is 86. 20 is 68. 10 is 50. 104. 122. I mean, it's 32, and then backwards is a little bit harder to remember. It's still 14. 20 is 4. 30, 22, 40, 40, right? It's pretty easy to remember these. 68, 20, 30, 50, 68, 86, 104, 122, 140. And you never have to get up to that point anyway, right? Temperatures, just ordinary, like weather temperatures, are not going to be much over 40 usually. Occasionally we get to 50, I guess. But so, pretty easy, huh? Do another one. I can do an eraser here and try to do this again. Oh shit. Okay, I didn't mess up. I don't want to erase my scale. All right, let's see. I'll leave that there. I'll take all this. Whoops, no, I don't want to do that. This is funny. You can't see this, but this thing is just. It's so far lagging from the movement of my little pen here. All right. So we'll do another one. Oh, I know what. I'll look at the temperature right now outside. It's 4.3. It's 4.3 degrees out there. So if you're in America and I told you it was 4.3 degrees, you'd go, "What? That's not cold," but it is quite cold. It's only 7:30. It's already down to 4.3 degrees. All right. So how do you figure 4.3? That's pretty close to 0, isn't it? So that's how I would figure it. I would just say 4.3 times 2 8.6 minus 10%. We don't need the dot there. Forget that dot. That dot's not there. What did I say? Minus 8.6. So that's going to be 4, 7, 7. Did I do that right? I think I did that right. Plus 32. $39.74. So it's almost 40 degrees. I'll do that in the calculator just to see if I did that properly, just to double check myself. 4.3, whoops. 4.3 times 1.8. See that? Equal plus 32, 39.74. I got it right. That was kind of easy, wasn't it? Oh, now room temperature in here. We can do that. It's 20 degrees. Oh shit, that's too easy. We know that's 68. 19.9. It just went down. It just went down to 19. What was that? 20 degrees. Now it went down to 19.9. So, yeah, we know it's like 67 degrees now. 67 point something degrees in here. Almost 68 degrees. So see how easy that is. I'm amazed that I haven't even had to use my. I used my heater one day so far in October, which is and it's been below freeze. We had a hard freeze a few days ago, and we had one last night too, pretty much. And I didn't even cover up my plants, but they did okay. My kale did okay. My tomatoes are gone anyway, so. Yeah, I haven't even had to use my heater at all because this place is so well insulated, and I've got all kinds of thermal mass in here. Yeah, if you want to keep warm in the winter, and you don't want to run your heater so much, for a number of reasons, you know, you can have a lot of thermal mass. What I do is I fill up jugs of water. Let's see some there around here. You know, here's one here, and I put like this, you know, just a 3-liter jug of water, and I've got them all over the place. And so if you do that, water has one of the most highest thermal mass that you can have. The thermal density, the specific heat capacity of water is higher than just about anything, and it's cheap, and it's the easiest way to get thermal mass into your living space. So that's what I do. And you don't have to have it out in the open. You can hide them in drawers, or behind furniture, whatever you want. You just have these bottles of water all over the place. And I've got a ton of them around here. And they're not that heavy. It takes a lot of those bottles of water to make a person. So, if you had 5 or 10 people in here, that's about how much water the water weighs. So you don't have to worry about that. But yeah, just get as much as you can of water hidden around somewhere, and it holds the heat. When the temperature of the air is warmer than the water, then the water will warm up from the air, and when the which will keep the air from getting too hot. So like in the summer, if it gets, the sun's trying to heat up your house, your water is going to be cooler than the air, and it will absorb some of that heat. And what it ends up doing is it ends up moderating the temperature. Here, I'll use my little pen. We'll do that. Oh, Jesus Christ! I did half of this without even putting this thing up here. I just realized that I did my stream without putting it back. I don't know when I forgot to do that. Jesus Christ! I don't know how long it was like this. Oh my God! All right, let me show you what this looks like here. God, I wonder how long I had that. Undo. Oh, eraser. All right. Yeah, I can erase all this stuff. Yeah, this was a learning stream for sure. Learning how to do this thing with this. God, I wonder how long it was like that. Jesus. And old Mary there didn't clue me into that it was messed up. What were you doing there, Mary? How come you didn't tell me? I've got a chatter. I've got a bot chatter here that was put some stuff into my chat. I should probably ban her or something. I guess I'm supposed to do that for Twitch. I'm supposed to ban people who do that. It's not, I don't know if it's spam or not. It's probably a bot, but I don't know for sure. I don't know if I should ban it or not. Yeah, I don't know. It wasn't like the bot just came and spam stuff. They said something first. So, all right. So yeah, like you have a house. All right, and you put all the bottles of water in there. Just put them all over. And then when in the summer, when the sun tries to heat up the house, the temperature in here, inside the house, will go up. But then the water, which is cooler than the air, will absorb some of the heat from the air, which keeps the air temperature from going up too high. So what you end up with, if normally in your house your temperature swing would look like this, during the day it goes way up here, and then in the night maybe it goes below zero, and like this. If you put that water in there, it'll smooth that out. So during the day it might not get so hot, and then at night it might not even get. See, that way you don't have to use your heater. Oh, that's not zero. You get the idea. I guess usually it would never go below zero, but you don't have to use your heater, or if you do use your heater, you don't have to use it as much because you don't have these extreme swings of temperature. Let me try that again. God, this thing is just bizarre how slow laggy it is. Okay. Okay, so suppose this is your thing here. And this is 0 degrees on the y-axis here. This is time. During the day, suppose you start, like, maybe it's 50 degrees in your house. We're talking winter, okay? And then and the sun comes out, and normally it would heat it up to, you know, maybe 80 or something, say, in your house. And the sun goes down, and your house right away loses its heat and goes way, you know, almost to 0. I should say almost to 0, not completely to 0. So maybe it comes down, it gets down to 40 in your house without anything. And the next day it gets up to 80 and down to 40. That's without any thermal mass in there. But then if you add thermal mass to it, it might look like this. You know, maybe it starts at 40, and the sun comes out, and the air temperature starts to go up, but this thermal mass here, this water, will start to absorb some of that heat and prevent this from getting too high. And it won't go up to 80. Maybe it'll only go up to 70 or something. And then at night, when the sun goes down, the air temperature will start cooling down, and it will get below what the water temperature is, and then the water will start releasing some of its heat, right? That's the law of thermodynamics, right? The entropy, right? The heat goes to where it's cooler, right? It wants to even itself out all the time. So instead of going down here to 40 degrees, maybe it only goes down to 50 degrees. And then the next day it goes up again, you know, 70, and down to 40, you know, or 50 or whatever. So in this case, you know, it might get so hot that you want to put your air conditioner on. Maybe not, but if it dips down here to 40, then you can turn on your heater here. And you run your heater from here to here to try to bring the temperature back up. And the next day, same thing, you run your heater. But in this case, it goes up to 70, you know, you don't even have to worry about using AC. And maybe it goes down to 50. You know, you put a sweater on, you know, you don't even have to run your heater. So it's just, you know, it's just a lot better like that. Another thing you can do in the winter to try to stay warm is to have a warm room in your house. Just don't worry about, just have like one or two rooms in your house that you keep warm, and the rest of them you just let them go to whatever temperature, and just give them enough heat just to keep them from freezing, you know, to keep the pipes from freezing or whatever. But just have like one or two rooms that will that you warm up. That way you spend a lot less than money on heat for your place. So this is especially good in places where like the cost of gas or heating oil or whatever has gone way up. You can save a lot of money that way, and you don't use as many fossil fuels that way. So that's kind of cool. God, I wonder how much of this I screwed up. God, I wonder how much of this was not even visible when I was doing this. Cause I just realized that OBS had not switched that over. I must have switched it and then didn't switch it back or something. God, what a mess. Maybe I'll do this stream again tomorrow or something. Maybe I should stop this and then see how it looks. And redo the part that isn't. Yeah, let me do that. I'm going to stop the stream. And then and restart it and redo that part that we didn't do. That'll give me more practice also. All right, I'll be right back. Oh, I should do this. All right, I'm not really done. I'm going to restart the stream here.